Have you ever heard someone say a neural network is just math? It almost sounds dismissive, kind of like saying a giant skyscraper is just bricks. But what if I told you that simple idea is actually the key to understanding how AI works? So, how does just math manage to recognize your face in a photo or even write a piece of text? Let's break it down together. Imagine you're trying to teach a computer to recognize a cat. You could try writing thousands of rules, like if it has whiskers, it's a cat, or if it has pointy ears, it's a cat. But that approach just doesn't work. What about a cat with folded ears or a cat facing away? It gets complicated fast. Instead, we use something called a neural network. It all starts with the input. To a computer, an image is just a grid of numbers representing the color and brightness of each pixel. These numbers are fed into the first layer of the network. This layer is made of neurons. Each neuron is basically a tiny, simple calculator. It takes in numbers from the input, multiplies each one by a weight, adds them all up, and then passes that total through something called an activation function. Think of the weights as importance knobs. For a particular neuron, some inputs might be more important than others. The activation function then makes a decision. This simple step is crucial because it adds what's called nonlinearity. But one layer of these neurons isn't enough to do much. So we stack them, creating a deep neural network. The early layers learn to spot very simple things, like basic edges or patches of color. The next layers take that information and combine it to recognize more complex shapes, like an eye or a nose. Deeper still, the layers can piece those shapes together to recognize a whole face, or in our case, a cat. That's the structure. Now, for the learning part, we train the network by showing it thousands, even millions of labeled images. At first, its guesses are completely random. It might look at a cat and say, "Dog." When it gets it wrong, a clever algorithm goes back and slightly adjusts all those little weight knobs throughout the network to make a better guess next time. This process of trial and error repeats over and over millions of times until the network gets really good at it. After all that training, the network is ready. We call this the inference stage. You show it a brand new image it has never seen before. The pixel numbers flow through all the layers, undergoing millions of lightning-fast multiplications and additions. And at the very end, out comes a final prediction: cat. But it is the incredible scale of it, all millions of simple calculations working in perfect harmony, that creates something that looks and feels intelligent.